Well, hello. Today we are going to be talking about subtracting fractions. And specifically, we're going to start out with subtracting fractions with like denominators. So let's get a visual of what that might look like. So you can see that here, if we have a whole, in other words, we have 6. So just like in the past, our whole rectangle here would represent like a value of 1. And then we break this up into 6 equal parts, or mostly equal. And then what we have, here we go, just do that. Now we've got 3 out of the 6. And if we want to represent taking 2 away, it's very easy. Just like in the past, we would just cross them out. And so you can see if we have 3/6 and we take away 2/6, then what we're left with is just this one right here. In other words, 1/6. Okay. So that's all there is. If we want to represent what that might look like with a model, let's see here, we can take our, we'll have our whole amounts here. And let's go ahead and we're going to make them into fourths. So we'll go 1, 2, 3, 1, 2, 3. Okay, so if we have 3/4, 1, 2, 3, and we want to take away 1/4, then all that we're going to be doing then is we're going to take this much away from here. So 3/4, take away 1/4. Again, this might seem very simplistic to you, but the idea here is that one's going to go away, and all that we're left with is just these two. In other words, we're going to have 2/4 left. So we can say that 3/4 minus 1/4 equals 2/4. Okay. Now, hopefully you look at that and you say, oh, just like with addition, if we have common denominators, then this is pretty easy. Okay, and so go ahead and you can do the model for this if you'd like. It's posted online. But if we have 4/5 and we're going to take away 2/5, then notice that our denominator is going to stay the same because our whole amount is broken up into fifths. And so we have 4 of them, take away 2 of them, represents 2/5. Okay, so just like we did when we were adding fractions, if you have a common denominator, then that's all there is to it. Super simple. Right? So notice here that we have twelfths and twelfths. So what we've got is 7/12 minus 5/12 equals 2/12. Then the last part of this, we're going to say, I know that a 2 actually can go into the top and the bottom. And so that's going to turn into just 1/6 would be our final simplified answer. Over here I have 17/24 minus 7/24. I can see that once again I do have those common denominators right there. So if I've got the common denominators, that means I can keep the denominators. And this will just end up being some 24ths, right? 17/24 minus 7/24. I have common denominators, so I have equal size parts, and I'm just taking away 7 of those. That leaves me with 10/24. Now I see these are both even, so just like we did before, we can divide the top and the bottom by 2, and I get 5/12 is my final simplified answer for that. Okay. Let's look down over here. 56th, yep, common denominators. So all I got to do is take 43 minus 19. Some people like to write it like this. They'd say 43 minus 19, 56th. And that's just totally fine. So when I think of doing this, I think of 43 minus 20 is 23. And I got to add 1 back on. So 24, 56th. Here's one that I know 8 goes into each of these, right? So we'll divide the top and the bottom by 8. We're just reducing fractions here. That's going to make 3/7. is the final answer for this problem. The next one here, I've got 23 28ths minus 9 28ths. Again, common denominator. Common denominators are good. That makes this very easy to do. We're just going to go ahead and subtract right across the top. I keep 28ths down here, and I've got 23 minus 9. That's going to be 14. And then 14 28ths, I know that 14 goes into each of those. So this is just going to be a 1/2. So that simplifies all the way down. If you didn't see that, that's okay. You could start out by dividing a 2 out of each of these, and you get 7/14. And hopefully you would spot that 7 also goes into 14. Okay, so here we've got a little word problem. A candle was 11/12ths of a foot. In other words, like 11 inches, right? And after burning for 3 hours, the candle was 5/12ths of a foot. In other words, 5 inches. Now, if I just wrote them like this, if I said 11 inches and 5 inches, most everyone would have this be super easy. You say, how long was the candle? How much of it burnt over that period of time? Well, you would say, you'd do this, 11 minus 5, and you'd say, oh, 6 inches burnt off of the candle. Well, instead of inches, what we're using is twelfths. You see, twelfths is like a label. 11/12ths minus 5/12ths of a foot equals 6/12ths. We kept the label. All right, 6/12ths foot. And of course, you know that 6/12ths of a foot does equal 1/2 of a foot, which is the same as 6 inches. But it is asking for this. It says the length is in feet, so 1/2 of a foot. That's how long our candle is. Okay. Next time we'll be looking at subtracting fractions with unlike denominators. All right, good luck.